Okay, next we'll learn project network analysis using part and CPM. Using part and CPM. So let us first define what is a project. So a project is a unique time-bound activity which has a single goal to achieve, and it is constituted of several small activities, and it is important to find out the total time required to complete the project. So project has an ultimate goal, ultimate objective, and to reach that end objective there are small activities to be completed, and the activities are interrelated activities, and there is obviously for the project there is a time is given, a time bound activity, and you have to complete the project within that particular period of time. But to, like example, say suppose you want to make your house, you want to make your building, your home. So you give yourself say 1 year time to build your home. But to build home you have to first find out a land. Then when you find out a suitable land within your budget, then you have to purchase the land, you have to register the land, and after registering the land then you have to go to the make the plan of your house, and then go to the municipality to pass that plan, and after all these activities are done, then and then only you can build your house according to the plan, and then only the actual construction starts. So all this, before doing actual construction, all those activities which are interrelated has to be completed first, and each and every activity like finding the land, suitable land to make your home, then purchasing the land, then registering the land, and all the activities, all of them are interrelated. Unless the previous job is completed, the next job cannot be completed. So, and every job requires some time to complete. So, and after you complete all these previous jobs, then and then only you go to the next step, and ultimately all the activities are to be completed within the time within this year. Now, as you know, if you are planning for the year, for this year, the activity, and you make your budget, your estimation of the land buying and your building, making your building plan, and the cost is estimated according to the cost that are prevailing in this year. But if the time extends, if you cannot complete the project within the year, then the time extends, as well as the labor cost and other costs also increases. So according to the plan, if you cannot go, then if the time goes beyond that, then the project cost also increases most of the time. As you are saying, there are right now there are several costs are going on, several projects are going on, like the metro rail project, and now due to the lockdown, due to the COVID and other things, most of the projects are stopped. So it will increase, because as the time frame that has been determined earlier for these projects will also be increased, and hence the cost will also increase. So if you cannot complete the project within the period of time, within the stipulated time, then there is an effect. Mostly there is a negative effect. Most of the time the costs increase. So it is very important for a project to be on schedule, and the project has to be completed within the stipulated time. Otherwise there are certain penalties. So Now, how this scheduling can be done in case of project? So, as I have said, project network analysis. Now, let us define what is a project network. So, project network. Let's define project network. Project network is a graphical representation of projects activities to reach an ultimate goal or end objective. Now, in case of ultimate goal and end objective, the smaller activities in the project are interrelated, and smaller activities are interrelated, and the graphic representation is integrated, and the representation shows the interrelationship, you can say interrelationship, and a relationship between the activities their precedence and succedence. The smaller activities in the project are interrelated, and the representation shows the interrelationship between the activities, their precedence and succedence, and their dependencies. So, for example, we will show a project network this way. The A, B, C, D, E, F, G, H, I, and J. Suppose a particular project network could be given is consisting of several activities like A, B, C, D, E, F, G, H, I, and J, and the circles represent the nodes, and so we are numbering the nodes 3, 4, 5, 6, 7, and 8. So generally an activity is represented as Aij. Aij is an activity between ith node and the jth node, and here it is to be remembered that the nodes are instances. They do not consume any resource or time, and activities are in between the nodes. The activities consume resources or time. So Aij represents the activity between ith node and the jth node, and always activity is pointed, an arrow is given, shown as an activity, and there are certain rules of numbering in the project, as you can see that the number in the arrowhead is greater than the number in the arrow tail. The number in the arrowhead must be greater than the number in the arrow tail, and the time the activities actually move forward, and that's how the activities are being done. So this is a project network graph representation of a project which is consisting of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 activities. So this representation is of 10 activities, and the 10 activities, 10 smaller activities, and each of the activities are having some duration. So let's give an example. So if I am writing that particular graph as a precedence and success relationship, so it could be written as activity duration in days, maybe, I mean days, in minutes, in hours, whatever, all of them are in the same denomination, predecessor. So say here for this particular graph there are 10 activities: A, B, C, D, E, F, G, H, I, and J, and so durations are like 10, 12, 8, 9, 15, 21, 7, 16, 11, and 5. Suppose the duration in days. And from the graph we can see since A and B are the starting activities, they do not have any predecessor. So predecessor for A and B are null. C's predecessor, you can see from the graph, C's predecessor is A. So C's predecessor is A. D's predecessor is B. E's predecessor is also B. F's predecessors are both C and D are the predecessor of F. Then G's predecessor is also C and D. G's predecessors are also C and D. Then H's predecessors are E and F. See here, see from the graph, H's predecessor E and F. I's predecessor is G, and J's predecessor is H. So that means, now what is the meaning of predecessor? Let's explain. The predecessor means unless that particular activity is completed, the next activity cannot be started. So here F's predecessors are C and D. That means F can only start when both C and D are completed. F can only start when both C and D are completed. Similarly, E's predecessor is B, implies E can only start when after B is completed. So from this predecessor and successor relationship, our objective is to draw the network graph, and then using this duration we will calculate the critical path. We will come to that, what is critical path and critical activity and duration of the project. Now what we can do from this predecessor relationship, we can also calculate the successor relationship. Simply, as we can see, so here A does not have any predecessor, B does not have any predecessor, so that implies A and B are starting from a particular node. A and B can start simultaneously, and that implies that A and B are the starting points. Now, so here if you see the picture, the network diagram, here you can see A's successor is C. C's predecessor is A, implies A successor is C. So here when we are trying to write the successor of A, we will check the predecessor column. In the predecessor column, where I can find A. If I can find A for somewhere, then for that particular activity, that is A is predecessor of C, that means C is successor of A. So what we'll do, we'll check where this activity A appears. So here activity A appears in the for the activity of in the predecessor column. Activity A appears for the activity C. That means C's predecessor is A. That will imply A's successor is C. Similarly, for who are B's successor, which activity or which activities or which are the activities are B's successor, for that we will check the predecessor column where B appears. So B appears for the two activities. B appears for the activity D and B appears for the activity E. That means B's successors are both D as well as E. So as you can see in the graph, after B finishes, D and E starts. After B finishes, D and E starts. So D and E are the successor of B. So similarly, this way we can find out all other activities. So for C, we have F and G. For both F and G, C is predecessor of both F and G. So that means C's successors are F, G, and similarly that is for activity D. So D's successor is also F, G. Then again for E's successor, we will find out where that E appears in the predecessor column. So E appears in the predecessor column. Now E is the predecessor of H, means H is the successor of E. So here I'll write H. In case of E, E's successor is H, and similarly F's successor is also H. Then G, where I can find G. So G's successor is I and H's successor is J. So this is how we will find out the successor. And I does not appear anywhere in the predecessor column. That means I does not have any successor. Similarly, J does not appear in the predecessor column. That means J does not have any successor. So from this particular information, what we get is those activities which does not have any predecessor, are my starting activities. As you can see in the figure, that A and B does not have any predecessor, so they are the starting point of the project. So they are the starting activities of the project, and at the end, so where we are reaching the goal, so there I and J does not have any successor. That means I and J are the end activities. So from this predecessor successor relationship, we can find out what are the starting activities and what are the end activities. Actually, this particular for a project network, this is the information that will be given, and from that particular information we have to draw the diagram. Their interrelationship has to be found out, and after we can find their interrelationship and after drawing the network diagram, we can then only we can calculate the duration of the project. What is the expected duration? What could be the possible duration of the project? So if you can calculate the duration of the project, then you can estimate the cost of the project, and the other arrangements can be done accordingly. So you have to that the project network analysis gives you the planning part of the whole project, and this is very, very important aspect of the project organization, and also estimating the budget, and also estimating the cost of the project. Now, before going into the more details of Part and CPM or project network analysis, or how to calculate the time required to complete the project, let's discuss certain basic things of project network. Let's start with the types of project network that we have. So project network are actually of two types. Project network are actually of two types. One is called deterministic, and there are two types of models. One is deterministic model, and the other one is the probabilistic model. Obviously, for deterministic model, what we have is deterministic model or deterministic project network is that particular network where everything is known beforehand. Or everything is known beforehand means the activities, what are the interrelationship, what are the precedence relationship, what is the duration of each activity. Although in real life we know that we try to estimate the different activities, so we expect that that particular activity will be completed within that stipulated time. So in reality, maybe the activity times are not fixed always, but for the initially when we try to do some project, we assume that this particular activity, say this particular example that we have given, that activity A takes 10 days, activity B takes 12 days. That means it's fixed, it will always take 10 days. Activity A will take 10 days, B will take 12 days, C will take 8 days. So all this duration in days are fixed. When this is fixed or this is predetermined, that particular model is termed as a deterministic project network. No variation of working time is given in that case. So there is no variance of time. If that is the case, if it's fixed, then that will be termed as a deterministic model. And obviously, if there is a variation in time, like if the duration is not 10 days but between 10 to 12 days or 10 to 15 days for a particular activity, or there is a maybe sometimes it is 10 days, sometimes it is 15 days. So there is a variation in time when it is not fixed, not known beforehand, not known, but some estimate of the times are given, then that particular model is termed as the probabilistic project network model. So whenever there is a variation, means there is certain uncertainty will be there, and the project will not be completed within that particular, within a period of time, then there is uncertain that the project will be completed within not that period of time. In case of deterministic model, it will be certainty. Every activity is certain and every time is certain, and the project will be completed within the certain fixed period of time. So that will be termed as deterministic. In case of uncertainty, when the activity time varies, then that particular model will be termed as the probabilistic model. The deterministic model is solved using a process called CPM or critical path method. Critical path method. And the probabilistic model is solved using similar method or similar methodology, that is termed as PERT, PERT, or project or program evaluation and review technique. Evaluation and review technique. Now the example that we have given already, that is an example of a fixed duration, that means deterministic model. So this problem can be solved using critical path method. Obviously there is a similarity between the CPM and PERT, but and obviously certain dissimilarities are there, so we will discuss that in later. But mainly for a project network, determining the project time or determining the completion of what is the time required to complete the project is the one of the most important aspects. And also through this relationship of precedence succedence relationship, how the network can be drawn, how the relationship, how it can be graphically represented, that is also a difficult part. And that can be done through practice and processes. So now there are certain rules of drawing the network. Let's discuss about the rules of drawing the network. Now to draw the network, we have already talked about events and activities, and we have already said that events are represented by nodes and activities are represented by arrows. Nodes are instances. They does not require any time and activity. Activities are actually requires resource and time. Now to draw a network, we have to know assumptions can be taken. Only thing that is available is whatever relationship, whatever precedence access relationship is given. Using those relationships, you have to draw the network. Now, before drawing the network, certain things are to be kept in mind. While drawing the network, we sometimes make different types of errors. There are 3 types of errors we come across 3 types of errors in network. We come across 3 types of networks. First type of network is called error in while drawing the network is called the cycling. Now what is cycling? Cycling is, as you can see, say 2 activities can start from a particular node, but if 2 activities start from a particular node, they must end in different nodes, because their activities could instances of a activity, when it ends, their instance is different. So 2 activities, when they start from a particular node, they cannot end in the same node. So this way, drawing this way, so 2 activities A and B as starting from a particular node and ending in another node. So this is not possible. If this happens, this is called cycling. This is not way of doing the network. While drawing the network, you have to think about this and you have to avoid this kind of error. You cannot make a cycling. Or it is also possible, like if you are drawing the network like this, so it is going back again. If your relationship you are drawing this way, then it is also forming a cycling. This cannot be, this is not done, this is wrong. You have to avoid while drawing the network. 2 activities, if they are starting from a particular node, they must end in different nodes. Or the other way around, 2 activities can come from 2 different nodes but join in the same node, but their starting instances must be, if the starting instances are same, then the end instances must be different. Also, if their end starting instances are different, then their end instances could be same. They could be ended at the same instances, same point out. That is also possible. This is possible, but this and this are not possible. So this particular kind of drawing network is called cycling. Cycling should not be happening while drawing the network. You have to avoid cycling while drawing the network. So that is one type of error that can form during the network. Now second type of error is called dangling. Now what is the meaning of the term dangling? Dangle means hang out. Now dangling actually means no activity can hang around in the middle. No activity can hang around in the middle. Like, say I am drawing a particular network like this. So see, if you are drawing like this, then it shows that this particular project has two end objective. Here is one end objective and there is another end objective, and we have already told you that the project has only one end objective. So here this particular activity is hanging around. It must be connected with either some end node, or it must be connected with some in between nodes. This cannot happen in case of a network. This particular way of drawing a network is called dangling, and while drawing a network you have to avoid this dangling. Now dangling can happen in between certain activities, or it can happen at the end of the project. Now you have to draw in such a way so this thing does not happen. This kind of drawing is not possible in case of a project network. So dangling or hanging around in between will not happen in case of a project network. So this is also has to be avoided. Now third type of error is called redundancy. Now what is redundancy? Redundancy means redundancy is something which is not actually required, which is already there. If some condition or some relationship is given which already implied, like say if we are writing A is less than C and C is less than D, which automatic is less than means C's predecessor is A and D's predecessor is C. It automatically means A precedes D. So if you are drawing this, so first must be activity. So let's write in capital because we are writing the activities as capital, and so it must be A, then C, and then D. This is the actual sequence. It automatically means A precedes D. But here if I write another condition, if I write A is less than D, this does not make any sense. This particular condition is redundant because as A precedes C and C precedes D, it automatically implies A must be completed before, then and then only after that D can be completed. It does not require to explicitly explain this particular logic has to be given, or particular precedence relationship is not required. If it is given, then that particular relationship is called redundant relation. This is not actually required. It is already implied there. So certain redundant conditions are to be avoided, and sometimes those redundant conditions may appear confusing and may sometimes lead to certain wrong representation of the network. So these are the three types of errors: cycling, dangling, and redundancy. So while drawing the network, you have to draw the network in such a way that these three types of errors are to be avoided. So please remember, while redundancy is to be avoided, dangling is to be avoided, and cycling is to be avoided while drawing the network. Now the next question is how to avoid these three types of errors. Now how to avoid these three types of errors? Now most importantly, there is a very important tool in the drawing of network that will help you avoiding this network, and that is termed as a dummy activity. So let's explain what is a dummy activity. Dummy activity is actually a fictitious activity. A fictitious, T-I-O-U-S. Fictitious means, what is fictitious? Fictitious means not real, actually imaginary, which is not there actually. We have to imagine, we have to add into that particular activity. A dummy activity is a fictitious activity which is required to complete the proper planning sequence of a network, and which will be required to avoid cycling, dangling and redundancy. A dummy activity is a fictitious activity which is required to be put to avoid the errors in the network. Dummy activity is an activity, it does not require any resource, it does not require any resource or time, or it does not consume, I should use the term consume, it does not consume any resource or time, and it will be only there to maintain the proper logic of the network. To maintain the proper logic of the network. It will be only there. So again, let's define what is a dummy activity. Dummy activity is a fictitious activity which is required to be put to avoid the errors in the network. It does not consume any resource or time. It will be only there to maintain the proper logic of the network. That proper logic will be there to maintain. So like example, like to avoid cycling, what we'll do, we'll draw this way. We'll draw A and B, and if I am saying that C is an activity which require whose predecessors are both A and B, so I cannot draw A and B together, so I will draw this way, and this will I'll put a dummy at D1. So that means by this dummy this particular node falls here, and then this particular activity C starts. So by this dummy we imply that both A and B are predecessor of C. Obviously the dummy activity is shown in the network by a dotted arrow. So dummy activity is represented by a dotted arrow, and mind that also very importantly that dummy activity can only be put in proper place when it is absolutely necessary. This is very important point. When it is absolutely necessary. It means that you cannot put it any way you like. You cannot put it any way you like. Whenever you feel like you just put a dummy activity. It is not like that. You can only put the dummy activity when it is absolute required. That means, like in case of cycling, as I have shown here, like to avoid these errors in case of cycling or dangling, that you can put a dummy like this, so that to avoid dangling you can use a dummy activity, to avoid cycling you can use a dummy activity, and redundancy is actually not required, so it is already there, so don't require a dummy there. But when it is absolutely necessary, when without dummy you cannot do anything, without dummy you cannot proceed further, we have to put dummy there. And mind that you cannot, while in the project network, whatever is given you have to maintain that precedence relationship. You cannot assume anything extra from outside, so you have to put dummy to maintain the proper logic of the network. So dummy activity is something which helps you avoiding these errors. Now, as I've said, so drawing the network is required, the nodes, and so for in a network diagram we will be having nodes and activities, and sometimes we'll be having also dummy activities, and the nodes are numbered. As you can see, we have already numbered the nodes are 1, 2, 3, 4, 5. So generally we use the natural numbers put in the node. And only thing while drawing the network, it is important to remember that the how you number the network. I have already stated earlier that to number the network we have to follow the rule that the number in the arrowhead must be greater than the number in the arrow tail. We have to remember that if this is 5, then this number must be greater than 5. It could be 6, 10, anything, but it must be greater than 5. And generally we follow 1, 2, 3, 4, 5, 6. So the natural number. So we follow the rules. We follow the network this way, and I think these are the basic information that is required to draw the network. And now let's use this information and whatever we have discussed till now for drawing some networks and some diagrams, and after that we'll try to find out how to determine the duration. Okay.